Login accepted.
So, welcome and thank you for joining us. So today we are going to look at code, but a little bit of less code or low code. But mainly we are going to look at the less code approach to this. So very quickly about me, my name is Maciej Swiderski. I'm an independent software engineer and consultant, very big enthusiast of workflows, as you will see today. I'm as well the creator of the Automatico project, which we are going to use for the demonstration today, and occasionally tweet or blog about workflows and software development in general. So starting with low code, if we trust the analysts of our industry, they claim that the low-code platforms and low-code solutions will become more and more popular around the enterprises. And even though we want to trust them, and most likely it will happen eventually, there is always a trade-off from the developer perspective. So low-code usually attracts or targets the business users, or the less technical users, to give them a possibility to quickly do something that doesn't have to be kept and maintained for months or years. Sometimes it's just for a couple of weeks to do the campaigns and so on and so forth. It usually comes with a sort of a user interface, a graphical user interface to quickly assemble things, not really develop, but more of assemble. So it comes with a bunch of predefined features that allow you to actually do the assembly. And it usually comes with a constraint, right? So it means that you're put in an environment that is suited for certain things, and they are supposed to be easy, but within those boundaries. So it's not really that appealing for developers, right? So it's more and more towards the person that can do quickly something that is responsible, something that is important for their business at that particular point in time. On the other side, the less code is definitely targeting the developers, because the less code is about to make you as a developer more productive by simply focusing on the business logic, which is specific to your domain, rather than constantly repeat the same things and so on and so forth. So what is less code? It's just that. It's just less code. It's nothing more. It's not that fancy things around it. It's just that you have to write less and less code. And to give you a bit of a background on what the less code is we started like a decade ago or even more with the Spring XML, right? It was about to defining configuration of your application internals. The same with Hibernate to allow you to build the object relational mapping. So that was already less code, right? You kind of shifted that towards the configuration, but you had to write less code. Then we have, with the Java 5 introduction, the annotations. So annotation allows us, again, to kind of slowly phase out the XML stuff and write less and less code. Spring Boot, introduction of the auto-configuration, which simply examines your project dependencies, figure out what will be the initial set of things that you need to have to just start and run. Again, less and less code you have to write. You have to less configure, you have to less write, and so on and so forth. Lastly, from the examples I wanted to show today, is the wiring. Like, imagine that, if you recall how much work you had to do to actually connect to a JMS broker, for instance. Gen-day lookups and queues, connection factories, and so forth. Now you can simply do the JMS listener from Spring or the incoming from the micro profile. That's it. Obviously, you need to still configure where the broker is and so on and so forth, but it's less code that you need to actually do. So if that's the case, we are kind of already get used to less code. We already have less and less code in our code base to actually fulfill a particular requirement of our business. So what could we do more? So this is where I would like to introduce you to workflows, and workflows are actually starting to be popular again. They were popular back in 2000, with the big vendors promoting it as the high-level things that will solve everything, will be on top of everything, the highest level of abstraction. These days, they are usually put in context of service orchestration, which, in my opinion, is the biggest misconception around the workflows. They can do way more than just service orchestration. One of the examples we're going to see today But in general, when you look at both our industry and our lives in general, everything can be actually a process or workflow. Even simple opening the door is kind of a workflow, or going to a grocery store, it's a workflow. But at the same time, it doesn't mean that everything needs to be expressed as a workflow. Workflows allow us to simplify things, and especially simplify the communication between the team members. Back in the days of the big marketing campaigns around BPM, it was that it is about bridging the gap between business users and developers. Right? That was the holy grail that, yes, once we do the workflow, it will solve all the problems. Business will understand what we do, we understand what business wants, and so on and so forth. That didn't play out right? So you can still use the workflows, but on a different levels. It's not always that it needs to be outside of your application. It can be actually the internal part of your application to express your business logic. On the other hand, the workflow automation comes with a bunch of features that allow you to actually, again, write less code. You can do a lot of things that the workflows can do for you. And one of the most important aspects of workflows is the isolation. And in workflows, it's by design. So first, you have the workflow definition, which is kind of a blueprint. And then you have instantiations of those blueprints as the workflow instances. Each and every workflow instance is completely isolated from the others. But at the same time, it is responsible for not just the flow of information, but actually keeping the state, keeping the data, and communication between each other. So with that, the simple question, why workflows, right? What's in it for me? And I think the simple answer to that is we all start with that. We all start with the whiteboard. We want to break down the things we are going to build. And you usually do that with expressing them as kind of a flowchart, box by box, connected with arrows, and so on and so forth. So why not take it further? Why to not make it actually runnable? If you can already express and break down your business logic into something that you can understand, let's make it runnable as well. So with that, I would like to introduce you to the Automatica project, which is essentially a framework for building services and functions based on the workflows. It uses the workflow as kind of a programming language, very limited, because it has the set of information you need to do. And it comes with three main concepts: workflow as a service, workflow as a function, and as a function flow. Depending on what target environment you want to go for, you will choose one or the other. Workflow as a service is the most typical microservice kind of approach, where the function is to make the workflow execute from the beginning till the end as a single function, and you can deploy that as AWS Lambda, Google Cloud Function, Azure Function, and so on. It completely abstracts you from where you actually deploy that. And function flow is a chain of functions. So you can simply model your business logic as one thing, and then at the build time, it splits it into functions and it invokes them based on the invocation context, meaning the data it actually handles. We're going to look at the workflow as a service today as part of the demonstration. If you are interested in the other ones, reach out. I can provide more information on this. And Automatic covers quite a few use cases. The most common are the event streams. So you can have workflows triggered by the events. And either goes from the Apache Kafka or IoT through MQTT. Business entity lifecycle, this is actually what we are going to look today. And the database record processing, so that means you're focusing mainly on the data aspect of it and build the lifecycle around that. Service orchestration, something that is, to me, a kind of an obvious fit for workflows is the Kubernetes operators. It constantly does the same thing. You model it what it should do, and based on the events that come in, it just reconciles everything. So that is exactly what workflows are for. And last but not least is the human tasks or human-centric workflows, where you have a lot of human actors involved, or you have the batch processing, which is usually triggered by time or some other events. It's open source, and it's built on top of Quarkus and MicroProfile. So that was just to set the stage. We are going to simply jump to actually the live coding. But let me introduce what we are going to build. So we are going to build a service that is inspired by the automotive industry. We are going to build a service that is responsible for managing the life cycle of a part. In automotive, any kind of vehicle is built out of parts, right? But to build a vehicle, you need to build a part. And part has a life cycle. We'll look at a very simplified view of it, both in terms of data and the life cycle of it. But it will give you the kind of a view on what you can do to follow to make sure that you can cover the complete life cycle of it. So few requirements that we put in front of us for this exercise is that the service needs to handle the life cycle, so different phases of it. Parts need to be uniquely identified by the part number. The part number is the ID that is going to be used always to interact with the service, so you don't have to have any additional identifiers of it. Parts can be accessed at any time. Part has well-defined data model, and parts go through the life cycle phases. And last but not least, we want to make sure that, first of all, it can be accessed through the service API. So here we're going to look at the REST API and GraphQL API for it. But in industry, automotive industry, it's usually extremely important to actually notify others about the changes, especially around the parts. The product development team goes through different phases of the part lifecycle. Those information needs to be broadcasted. So if you are productizing a part, you need to reach out to the aftermarket and so on and so forth. So what we wanted to explicitly do as part of the service is that we push out the information out of our system as well, so others can simply subscribe to that and react to those information, do whatever they need to do. All right, so with that, we can start building that from scratch. We don't have anything, so let's jump. Hopefully this, not wrong side. Hopefully that will be big enough. I did it for the font for seasoned and senior developer. So that is when you usually start having problems with your eyes. So it should be big enough, but hopefully we can either zoom in if there will be need to. So let's start by simply creating a Maven project. We create it from the archetype. All right, so we just grab the most basic one. All right, yes, of course. So what it does, it just creates out of the archetype a project that is the most basic setup of the Automatica project that has the basic features of it. So first of all, what I wanted to give to the service is that we have something called a process management add-on. Automatica has a set of add-ons that you simply add to it to equip it with more capabilities. So we have the process management that allows you to look at it from the workflow perspective, so you can track where it is, how many instances you have, in which places they are, what are the data sets, and so on. I will just add another one as soon as I copy this. And instead of process, we want to have the user task as well, because we will have a single user task there to manage the interaction with the human, with the part designer. So the first thing that I wanted to start is to build a data model. Again, a very simple one. So we simply create a Java class here. Part info. The part information will have just 3 fields. Name. Description. And then last one, revision. Just create the setters and getters for it. Right, so that gives us our basic data model. Obviously, in the normal situation, it will be way bigger. It will consist of number of nested objects and so on and so forth. But just to keep it simple for the sake of this demonstration, next thing, we'll just create our workflow. There we go. And then just create. Examples. What is important here is that the process ID becomes our identifier of the service interface. And you will see it as soon as we just run that. But before we do that, we will just get a very simple thing. So we said that we want to have something that is going to represent our identifier, the part number. So we can simply create a data object here called part number. Give it a type. Everything here is strongly typed. So we can actually make use of that as part of our service interfaces. So everything that will be describing our service will actually have all the type information and so on and so forth. So we have the part number. We want to give the information as well. So this time we wanted to make use of the part info class. So we simply add that. And just name it info. And last thing, we wanted to track our life cycle, so we create another data object called status that will keep track of what the state of the part is. So that is very simple data model of it. So as you can see, you can already describe everything in the matter of visual aspects. So you have the options to easily say, okay, this is what we're going to have within the workflow. So now let's build the actual business logic of it. So we wanted to say that the first thing that we do as soon as we receive the part, we wanted to validate it. Right? So this is what is going to be really specific to our work. And it's not something that we can kind of bypass or get it out from outside. We have a certain rules, what it means to validate a part. So this is our specific logic to us. So you can just connect this. Service task will represent a call to a Java class, for instance, so CDI being in this case of using Quarkus and MicroProfile. Once we do the validation, we need to make a decision of what we're going to do, right? So we have the split here. So either it's valid or not, right? So if the part is not valid, we can actually it's valid to have all the documentation aspects directly here as well. So we want to end with an error. Error means that as simple as promoting that information to the caller, that something went wrong. So here what we're going to do is simply create our definition of an error that will return error 400. Again, this is the information that will be added to your service interface. Again, everything out of the workflow will be available for you, and then we want to attach the information to it. And let's just call it not valid. Simple that, and we attach the information that was actually given to that. So we can say that this element is invalid. Right, so that's one of the paths. The other path will be that we wanted to actually initiate the life cycle of it, and by that we wanted to start a design phase. A design phase will be a separate workflow because we don't want to make a single workflow that is completely bloated and just comes up with everything in a single place, right? So we wanted to make use of the process composition so you can easily bounce a particular business logic into individual parts, so we can easily expand from there. And for the sake of today, we're just going to end it here. So we have the very quickly view of what's going to happen. Obviously, it will be way more complex. In the real scenario, you will have multiple phases, you will have exceptional paths, and so on and so forth. So that needs to be tackled as well. But for the sake of this, let's start looking at what next we need to do. Because this is what we would do at the whiteboard, right? Just break down the business logic. Now let's make it executable. So what needs to happen to make it actually run? So here we want to add one more thing, because we want to track the information out of the validation, right? So we just add another one. This time it will be the Boolean and simply valid. So once we have that, we can say that in this case, it's a diverging since we are splitting into different places. So if we want to go to the call activity, we can actually just name it nicely. Design phase. So now we can say that if we want to go to the design phase, the part needs to be valid. As simple as that. The other one is the default one. So if the first one did not match, it will just go to the default path, and that's it. All right. So we just save that. So we have that, but this has no value, right? Currently, it's not set. We are going to set that based on the validation stuff. But at the same time, we don't want to expose this kind of information to our consumers, right? If it's valid or not. So we can simply make use of something that is called tags. So we can tag different data objects, and we can call it internal. That means that this data object will not be visible outside of the model itself. So it's purely for internal purpose, so it can track the information, but it does not leak towards the consumers of it. The same thing we do here is that we don't want to have the status to be managed from outside, right? So we again use tags and say it's output. So it will be available to be seen as what's the status of it, but it's not going to be set from outside. Again, tracked by the workflow itself. And here, the part number, one of the requirements was to make it an identifier of our instances. So again, using tags. And here we say business key. And we want to make sure that it's given, so it's required. And the same for info, we can say it's required as well. So those are the information that must be given when we start or create new part. All right, so that gives us the basic definition of our model. So now let's create the validation service. So here it is, again, the same thing. And since it's based on Quarkus, so it's CDI bin, and we just give it, we take the part number, part info, and this is the business logic that we need to implement, right? We need to simply validate. So let's say that if the part number length is less than 5, it's not valid. Otherwise, it's fine. As simple as that. So now we wanted to link that so the workflow can actually invoke it. So with that, we just go to our properties. Here we have the interfaces, so we can simply import this. All right, and so. Right, everything's found here, and just the operation. That's it. So now we can actually equip that with the implementations based on Java. Then we have the validation. Last is to simply add. Let's just open that for better visibility. All right. So here we do the data mapping. Simply that we wanted to pass the part number. As you can see, it already gives the type information. Part number. The second one will be the information. Same here. And lastly, we want to get the output of it and map it back to the valid one. All right, so that should give us pretty much everything we need to actually have something that runs. But the remaining part, actually I just forgot, is the design phase, right? This is a sub-process, something that is actually running in a separate, from the separate workflow definition. So just to save a little bit of time, let me just copy that. I'll show you what it has. So it has just the user task. As I said, that's why I added this additional add-on to be able to interact with that from the user perspective. So it will be a simple form, so you can actually enter data and continue there. So this process has identifier of design. So let's now do the wiring between the parent and the child process. So we do it simply here, just setting it that. And now we need to do the mapping as well. So we wanted to pass the part number. And then the other one is info. And we want to get back the status. All right. All right. And that should be pretty much it. If I did not make any mistake, let me just go to this folder and we start actually running it. As you can see, we created actually two classes that are really specific to our use case. So it's the part model and the validation service. So now if we just do a start of it. So what it does, it will create a service for us. By default, it will come out with the REST API. And as you can see, we have not done anything related to the REST API. Oh, obviously, I made a mistake. All right, where did I make a mistake now? Of course, this one is not needed. So we haven't done anything related to the REST API, right? So everything is just purely our business logic that should give us a simple way to get going. So we can actually use things from the Quarkus. So we have the dev UI with just by pressing D. We have everything that is running in the service. So you can see there is a automatic service that has a simple console. So it gives you a quick view of what's actually happening there. So it's purely based on the workflow definition we created. But what is more important is that it comes with the Open API, and you can actually look at the Swagger API of it. And here you will find a fully featured API generated out of the workflow definition. So it's pretty much the complete CRUD with all the phases included. As you can see, the first level parts is the top level process. Then the design is the design phase. So everything that was modeled is actually now a service. You can interact with that service. So for instance, if we look at the post to start of it, you can see that our data model consists of part number and the info. You don't see the status and you don't see the valid because they were tagged to not be visible as inputs. But on the other side, if you look at the output, the status is there because it was marked to be included. So now you have the complete information of the service exposed through the Open API. At the same time, the whole point of this is to not leak the implementation details, to not show it that it's a workflow. You're not starting new workflow instances, even though it's actually doing a new workflow instances, but it does not leak to your consumers. That means you can easily replace it with keeping the same API of it. And I think if you remember, we created this little fellow here, the error one. If we look at the service description, you will actually find it here as well. So it's part of your definition of the service. And it's even more advanced in the sense that it will actually track on which path this error can be thrown. So if it would follow like another wait state that workflow waits in a given state, and the error might follow, then it will be attached to that operation of that service. It won't be visible on the first one, on the initial one to create, but it will be in the further one, if you continue with the task and so on. So we can actually get going and start it by simply saying, remember our rule. It's always better. No, I don't. So now we have the part number of 3. As you can see, you get immediately the validation failure. So you went through that path, you returned that error, and you have the information attached to it. Again, we didn't have to write anything. It just came out of the workflow definition because it defines our business logic, so you can easily expose that. Now, if we create a valid one, we get the information with the status design, meaning that it actually went into design phase, the validation went smoothly. So we have now the options to actually look at this as well. There we go. We have a simple information about it. So we have the information where it currently is, what's the data model, with information about the sub-processes. So that gives you, this is completely optional, and usually it's not exposed to the real consumers. It's for your purpose to actually understand what happens. All right, so that gave us very quickly the REST API. So now we said that we want to have the GraphQL, right? So let's try to do that. So let's just first add the dependency to another add-on. QL, GraphQL. So by adding that dependency, it should simply create a service interface, not just with the REST API or Open API, but as well, as soon as it loads, we have the GraphQL now. This gives us a complete set of operations exposed as a GraphQL. So in case you wanted to interact with the features that GraphQL gives you, you can see that we have the queries, we have the mutations, and we have the subscriptions, something that we don't have in REST, the subscriptions. So GraphQL could give you that out of the box. The same, you can just create it, the parts in the same way. Here you have the options to actually explicitly say which fields you want to get back out of it, or you can even create multiple instances in a single request, right? Let's give it 2. Mark it with 6 and 7. There we go. Exact same thing. So it just goes through that interface, but the service is with the business logic in exact same way. So that allows us to smoothly work in both types of interfaces by simply saying, okay, I want to expose it as REST, or I want to expose it as GraphQL, or both. So that allows us to easily expand in terms of features without, again, writing any code for that. Because that's something that is not really specific to your business logic, right? So the business logic that is specific to you, this is what you must write. But everything else, the boilerplate code, could be actually derived from your business logic. Then we said that we want to have as well the options to push out the information to other systems. So for that, we're going to use Apache Kafka. So let's just add another dependency. This one, it will be a regular Quarkus. And here we're going to use small I. Is that correct? Yes. So by adding that, it will kick off with the Quarkus dev services, so it will spin up a Kafka cluster or Kafka server for us. So we'll have something that we can easily interact with. So let's just wait for that. We should get somewhere the port number. Find it out very quickly. Where is that? of course. Now the font is too small. All right, I'll figure it out in a second because it will reload once again. So if we want to push the messages from our workflow, we can make use of something called throw messages. Just grab this, just make a little bit of space, connect those two, so we don't lose the conditions. Here, I just wanted to call it publish message. And inside our message definition, we just create one. The name here becomes our topic name as well. We can provide it through the custom attributes as well, but by default, the name of the message, if it's not overridden in any other way, will become our topic name. And then we want to set the type. We want to publish the part info there. And by that, map the information. And that's pretty much it. That's all you need to do to actually publish a message to Kafka out of your workflow. And just, let's see if I can get the port number. It should be here. All right, so if we just go here, change the port. All right, we have it. No topics yet. So let's go to our service API and then just go here and create one. If you go now to Kafka, like here, we should have the topic. And if you look at the data, we have the message published there as well. It's by default a JSON serialized message. But what is important is that it actually uses the key of the Kafka record to be our part number. So that gives us the possibility that all messages for that part number will be placed on the same partition, will be in the order, and so on and so forth. So we can actually rely on that information being published. The same thing we can actually do on the end events. So as soon as we just finish it, as soon as, for instance, the part was retired, or deprecated, or whatever we prefer to call it, it will publish another message and finish it. So that gives us the main requirements from the business perspective, but as you could notice, I could create constantly the same part number, like 1, 2, 3, 4, 5, as soon as I made changes that reload the application. And the reason is there is no backend storage for it. So the workflows runs, and they kept the state in memory. So now we wanted to make sure that it's actually persisted somewhere. So to do that, again, another dependency. Just adding the MongoDB persistence. It will, again, restart the application, start MongoDB server, similar to what it did for the Kafka server. And now we will have a complete backend storage for it. So all the instances we create will be stored in MongoDB. So let's see if we can now find the port number of Mongo. This is the one. So if we just go to Compass, create new connection, just make it, where is that? Oh, sorry. Advanced, and just make it direct. So as you can see, we have a new database with 3 collections: parts, design, and jobs. Jobs are for the background tasks like timers, but parts and designs represent our workflows. So every single instance will end up in those collections. So if we go back again and create new part, and go back here, you can see that it is stored down. So we can now bounce the server or reload it. It will be kept there. So we have the same here. So if we now look at another requirement we had, that we said that we wanted to fetch the information of the parts based on the identifiers, you can simply make use of that as well. And there we go. Plus, we can actually get some sort of metadata, which is more specific to the execution, rather than the data model itself. So here you can see that we have the actual more information, what is the state of the instance, the tags, the links, start date, end date, and so on. So why we added the user management add-on is to actually do that. This goes immediately to the task for that particular user that is in context and allows you to interact with that from the human perspective. Those are like a default task, so they actually look at least as a form, but they are completely customizable based on the templates. So you can create templates either for individual user tasks or share them across different tasks, and you have complete set of features of Quarkus Qt templating engine, so you can do everything you need. You can load data from outside, equip it with additional logic like the JavaScript to allow you to do it more dynamically. But why I wanted to show you that is this, because if I complete it, the instance is completed, and if you look at Mongo, it's gone as well. Even though it was supposed to be stored, right? It was supposed to be there always. But the thing with the workflow is that it optimized on the storage as well by default, meaning that if it's completed, it's gone. But it's very simple to change that behavior. And you can simply just add a configuration property on instance and just tell it to keep it. So now everything will be kept. And you will see that as soon as we create new instance, let's open this one, exact same data, find it, we have it there. And then once again, let's get it from here. And we have the form as well, so you can easily interact with that. Done again. It's still there. We have now the status has changed, we have the end date. So now we have complete track of what has happened. It's there. One additional thing especially useful with Mongo is that you can actually set up the expiration on the workflow definitions as well. Meaning that as soon as it completes, it can calculate after what time it is considered expired. So this is like kind of applying retention policies of it. So it will automatically be cleaned up based on the Mongo time to leave indexes, and we simply scan that automatically by Mongo. If it finds that the particular expiration date is set, it will clean it up and remove it from collection. All right, so that was pretty much all from the demonstration. So let me switch back to the slides and quickly wrap up. We have 6 minutes left. So again, less code means essentially to be more productive, to let you developers focus on the business logic of your specific use case rather than being concerned with all the boilerplate code that you constantly repeat in every single service, like the building service APIs or connecting to Kafka brokers, MQTT, and so on and so forth. But it doesn't mean that the code does not exist. It's there. It's just simply written by someone else. Or, as in this particular case, generated based on the workflow definition. Workflows certainly can improve the visibility of the business logic, and it's easier to communicate because you keep pretty much on the level that you usually start with the breaking down of the business logic into particular pieces to make it possible to implement. And last but not least, I would say, if, again, analysts are right, and there will be more and more low-code solutions, and developers don't want to be the low-code developers, meaning just moving, just assembling things. but the less code is actually, together with workflows, is actually an enabler for low-code platforms. And I can tell you that from a perspective of building low-code platforms, it's a really big challenge. And as you can see at all the cloud providers, pretty much everything you do in the self-service portals are kind of workflows. You need to collect data, you need to validate data, and then provision different things, which is in the backend called through the workflows. So that could be an interesting future development when it comes to the business application in general. So with that, I would like to thank you very much for listening. Here you can look at the automatic itself. The QR code gives you the link to the website. The source code of this is there, but I need to just make it public project, so I'll do it right away. And yeah, reach out if you have any questions or comments or anything else. And with that, I can open up for questions if you have any. Thank you.